going to talk about some applications with the normal distribution. We've already talked about how to use the cumulative normal table. We talked a little bit about the fact that it only gives us proportions or areas to the left of the z-score, and we're going to be using that. But what we need to do is, we're not given z-scores in real life. And so what we're going to be needing to look at is converting our x values, whatever we're given in real life, to z-scores. And this is known as standardization. What we're trying to do is make it to where everything's on the same scale. We're wanting to make everything on that z-score scale where we have a 0 in the center and we have standard deviation of 1, so that we can compare items. Because if we don't have that, then we can't really compare. And so remember that z-score is calculated by taking our value minus the mean and dividing it by the standard deviation. And so if the formula kind of confuses you, go ahead and look at it in terms. Value minus mean divided by standard deviation. And so these are the exact same thing. One is in words, one is in the notation. Now let's look at those properties of the z-score. It follows the standard normal distribution, and it is that standard normal. So if something is not normal, then we can't use z-scores. So if something is skewed or anything like that, we can't use these. Values below the mean have negative z-scores. Think about a number line. And values above the mean are going to have positive z-scores. And what the z-score tells us is how many standard deviations the original value is above or below the mean. So if we look back up, if I have a positive 0.5, that means it's 1/2 of a standard deviation above the mean. That's what a z-score is telling us. We're going to arbitrarily round these to 2 decimal places. And that's only because our table, A2, is expressed that way. Remember that we have our whole number and our first decimal here, and then we have our second decimal place along the top edge. And so we're going to round all of our z-scores to 2 decimal places. Now let's look at a couple of examples, and all we're doing is going to find and interpret the z-score for right now, and then we'll come back and look at how we use this with the actual table. So a normal distribution has a mean of 15 and a standard deviation of 4. Find and interpret the z-score for x being 11. So this is the value. So we need to find our z-score. So we have our value of 11 minus our mean of 15 divided by our standard deviation of 4. Now, couple of different things. Yes, you can put this all in your calculator at once. If you do, make sure you put parentheses around that numerator, because you've got to calculate that numerator first. So put parentheses around the numerator, and then you can put divide by 4. Or you can do the calculation 11 minus 15, which will give you a -4 divided by 4. So you get a z is equal to a -1.00. And yes, I am going to put the 0.00 because of the fact that when we go into our table, we need to know what those two decimal places are. Now, whenever it says interpret the z-score, that just says that 11 is one standard deviation I'm sorry, whoa, I totally forgot. This should be a negative because I've got negative divided by positive. That's a negative. So 11 is one standard deviation below, because it is negative, the mean. Make sure you get your signs correct. Okay, let's look at an actual example with some real data. You're an aspiring doctor preparing your med school applications. First, you need to take the MCAT examination. You study for, that should say months, and manage to score a 510. The MCAT is scored on a scale from, a scale for each section, 118 to 132, and the exam as a whole, 472 to 528. According to this association, which is the makers of the exam, the mean for the MCAT score for the 2020-2021 testing cycle was 506.4 with a standard deviation of 9.2. So this right here is my mean. So my mean is 506.4. My standard deviation is 9.2. Find and interpret the z-score for your exam score. So your exam score is 510. So that's my x. So a lot of this, like these numbers here, don't mean a thing to us. These numbers don't mean a thing to us. You have to go through there and look for mean and standard deviation, and then what you're looking for. And so you have to kind of look at, okay, here's my score. Then we're going to calculate the z-score for this. Your score minus the mean score divided by the standard deviation. Again, you can put this in your calculator all at once. Make sure you put parentheses around it. Or you can do this individually. 510 minus 506.4 would give you a 3.6 divided by 9.2. So that would give you a 0.3913 and continuing. So if I round that to 2 decimal places, that's going to be a 0.39. So your exam score is 0.39 standard deviations above, because it is positive, the mean. And that's all that it's asking for whenever it's talking about interpreting. Okay? So try calculating some z-scores, and then in the next video we're going to talk about how to actually look these up on the chart.